Years ago, people went to great lengths to make rope. They stretched yarn 200 to 300 meters, sometimes down alleys, and secured it on hooks. Then they turned wheels to rotate the hooks, twisting the yarn into rope. This technique was called a rope walk. Luckily today, we have machines to do all the legwork. These ropes are made from thousands of nylon fibers that are finer than human hair, but stronger. To make rope, yarns wind around aluminum cylinders, pulled by a turning spool down the line. Then, 3 at a time, the yarns roll over another spool that applies a protective coating of urethane. Then they funnel through a distribution plate that holds them evenly apart. This ensures they're at an even tension, as a rocking spool twists them into one larger yarn. This machine is called the whirlwind. It twists the yarn and then winds it onto a take-up spool inside. A little arm moves back and forth, guiding the yarn so it winds evenly onto the spool. This is core yarn, and it'll be used to make other rope. Now, dozens of spools of nylon fiber unwind at the same time to make jackets to protect the core yarns. The fibers travel several meters over a network of rollers that act as guides and control tension on each individual fiber. They pass through distribution plates, as turning bobbins below twist the fibers into yarn. The platform moves up and down to evenly wind the yarn onto the bobbin. They place 48 of these bobbins on the maypole machine, so called because the braiding action resembles a dance around a traditional maypole. The bobbins spin and zigzag around each other as a machine pulls core yarn up through the center. Here you can see the rope being braided around the core yarn as it's pulled up through a die. This is the braiding action in slow motion. It produces a mountain climbing rope, strong yet stretchy because of the twist in the core of the rope. The rope winds onto the wheel as it pulls it upwards. Then it spills into a basket. A worker pulls out a sample rope to check its flexibility and strength. He bends it to make sure it'll knot easily. Now another maypole braider weaves a synthetic rope that's stronger than steel, yet lightweight and flexible. That's because the strands at the core are braided with a material called ultra-high molecular weight polyethylene. It's a high-performance thermoplastic. This rope will be used for advanced yachting. A pulley draws this high-tech rope through some metal pipes filled with steam. This shrinks the polyester jacket around the powerful core for a tight fit. These dancing bobbins do some fancy moves to produce different weaves around core ropes. They dip around and between each other in a choreographed sequence. But there are no worries about production hitting a snarl. If a yarn breaks, the machine simply shuts down. It takes 8 to 10 hours to make a bit more than 900 meters of this large utility rope. Now for the strength test. They loop a sample piece of rope around steel posts. This one is a nylon double braid, the type used for dock lines on boats. Hydraulic pressure pulls the rope upwards, while a computerized gauge measures the tension and detects the breaking point. Over 9,000 kilograms. That's the weight of a killer whale. Needless to say, this twine is just fine. Now for another test. They insert a steel probe, known as a fid, into some industrial rope, then place the pointed end into a hole. An electric motor forces the fid through, while a gauge measures the force it takes for it to completely penetrate the rope. It took 4.5 kilograms of pressure to push the probe through the rope, which means this rope is firm yet flexible. So now you really know the ropes about rope.